Okay, so what we are going to do is we are going to discuss linked list. So when when I say linked list, like generally it means single linked list. We'll be doing double linked list and circular linked list too. So let's see what a linked list is. So linked list is a dynamic data structure, which is something like this. Okay, so what it has is it has a container which can contain some values. It can contain a character, a string, integer, an object, whatever you want. For simplicity's sake, we will just put integers in it. So let's say we put 2, 5, 7, and the last one will point to a null. Okay, so for traversing this list, we actually need to access this list. For every accessing every element, we need a head. So we'll write this is a head. Okay, so and every node, what does a node contain? In this case, the node contains an integer data, and the second thing the node contains is a pointer to the next node. So these are the two things that a linked list contain. Let's in normal day-to-day programming, we actually do not write a linked list, but what we are going to do is we are going to implement a linked list from scratch, and we're going to write the linked list class and stuff like that, and then we will go to more difficult questions. Okay, so let's first create a class of a list node. So a list node. So it had a public integer data, and it had a public a list node next. Okay, so that was the two things that a list node had. I will make the constructor as private, and I will create a new constructor. So public, and it will have an integer data. Okay, so when the constructor is called, what we will do is we'll say this dot data is equal to data, and we'll say this dot next is equal to null. So what will happen is when a new list node is created with an integer data, the data will actually be assigned the value which is passed over here, and it will start pointing to a null. Okay, next thing what we will do is we'll create a class of linked list. Okay, so a linked list, if we see over here, minimum it needs to have a head node. So we will create a node, a list node head. Okay, after that what we need is I'll just create a constructor. So public a list node, a linked list. I'll just assign head is equal to null at this point. Okay. Oh, sorry, a linked list. Okay. So we have created a new linked list, and the head is null. Now what we want to do is we'll write two very simple function. One function would be adding a head, and another function is adding tail. These are extremely simple functions, and let's see how we can add a head and add a tail. Okay, so we'll write the function for the add head. Public void add head integer data. Okay, So what we need to do is we need to create a node which has this data. So we'll say a list node add is equal to new a list node data. Okay, so at this point an add node has been created. Data, whatever was passed, was added to it, and it is pointing to a null value. Okay, so let's say in this case, let's say if 6 was the data that we passed, so a new node called 6 was created and it is pointing to null. Okay, so next what we want to do is we actually want to check if the list is null. So if head is equal to null, which means there is nothing in the list. So at that point what we want to do is we will say head is equal to add and we return. Okay, so this is extremely simple. Next thing what we need to do is we need to check. Okay, so now the first condition is done for the head. Next, if we want to add 6 as the head, what we will do is instead of pointing to null, we will start pointing it to the head, and head, instead of pointing to 2, it will start pointing to 6. So this way we will actually change the head, and whatever node we added, that will become the head. So that's exactly what we are going to do in the code. So what we will do is we'll say add.next is equal to head, and add and head is equal to add. Okay, this is an extremely simple function. So we added the head. Now let's say we want to add a tail. So we'll say public void add tail integer data. So the first part will remain the same. We'll create an add node, and if head is null, then we'll make that as the head. Okay. Next, what we need to do is, let's see over here. Let's say if we, instead of adding 6 at the head, we wanted to add it at the tail. So what we will do is we will create a new node 6 over here, and it will start pointing to null initially, and then we will create a temporary pointer which will point to 2, the head first, and then we will keep moving till it reaches the last. So we'll keep moving this temp pointer so that it moves to 7. At this point what we will do is instead of this pointing to null, it'll start pointing to 6, and 6 is already pointing to null. So we have successfully added a node at the tail. Let's see how the code works. So we will say a list node temp is equal to head. Okay, and then we will say while temp is not equal to temp.next is not equal to null, temp is equal to temp.next. Okay, so we have figured that part out, and then we will say temp.next is equal to add, and that should do it. Let's test this program and see if it works. So we'll say a link list is equal to new a linked list, and we will say list dot add head, and let's say we add 2, and then we will add a tail. Let's say 5, and then we will add a tail again. Let's say 7, and we will add a, let's say add a head. So we'll add a head again, and the value, let's say, is 1. Okay, so at the end of this we should have 1, 2, 5 and 7. So let's put a breakpoint and then we will run this. Okay, so a list is created and the head is null. A list is created, head is now equal to 2, which is pointing to null. And then right now it is 2 and 5. And then it should be 2, 5, 7, and then it should be 1, 2, 5, 7. So at this point it should be 1, 2, 5, and 7 is pointing to null. So this is a very extremely simple class of a linked list. We will keep adding functions to this linked list class and do tougher questions. Thank you.